This video will discuss about the divergence in orthogonal curvilinear coordinate. How you will find out the divergence in orthogonal curvilinear coordinate. As you know, to find out the divergence, you have to find out the del of the vector function. That means divergence is for vector function and gradient is for scalar function. So here V is the vector function, and this vector function, suppose it is having three variables, that is q1, q2 and q3. And what you have to find out in divergence, you have to find out the net outward flux, and you have to divide with the differential volume. First we will calculate what will be the net outward flux. Suppose this is a parallelopiped piped, and in case of curvilinear coordinate, these these sides are not parallel. Okay, so consider a volume element which is no longer a parallelopiped, that is all sides are not parallel because they are curvilinear coordinates. Here we are considering curvilinear coordinates, so these sides are curvilinear. And here you have three sides. This is one side, this is another side, and this is the third side. That means three axes, you may say. In case of Cartesian coordinate, suppose this is x axis, this is y axis, and this is z axis. But here you have to take the scale factor. That is why the value along this direction, suppose along this direction I have taken h3 dq3, and along this direction I have taken h2 dq2, and along this direction I have taken h1 dq1. Because here we will consider the scale factor, as I have discussed in the previous video about the scale factor. Then what will be the differential volume? When you calculate the differential volume, you have to multiply these three. That means the differential volume will be equal to h1 dq1, h2 dq2 and h3 dq3. And that means the differential volume will be equal to h1, h2, h3, dq1, dq2, dq3. You have to also find out this differential volume. You need this differential volume to find out the divergence. And suppose the vector function, that means you have to find out the outward flux. So the vector function of three directions, suppose along the q1 direction the outward flux is v1, and along the q2 direction the outward flux is v2, and along the q3 direction the outward flux is v3, and we have to find out the total flux along q1, q2 and q3, and you will add the total flux to find out the divergence. And what will be the outward flux along q1 direction? The outward flux along q1 direction will be equal to del of this value v1 dq1, h2 dq2, h3 dq3 with respect to q1. So rearranging the terms, this will be equal to the change of this factor, that is v1, h2, h3, dq1, dq2, dq3 with respect to q1, partial derivative of this factor with respect to q1. Similarly, you can also find out the outward flux along q2 direction by taking the partial derivative of v2, h2, h1, h3, h1, dq1, dq2, dq3 with respect to q2. Similarly, the outward flux along q3 direction, you will take the partial derivative of v3, h1, h2, dq1, dq2, dq3 with respect to q3. Now you add the three partial derivatives to find out the net outward flux, that is the net outward flux along q1 plus the net outward flux along q2 plus the net outward flux along Q3. And how you can find out the divergence? By dividing the net outward flux with the differential volume. As I have discussed, the differential volume is H1, H2, H3, dQ1, dQ2, dQ3. So if you divide this differential volume with this net outward flux, this factor, then you can find out the divergence. So divergence can be found out, you see, just by dividing this net outward flux. This is the net outward flux. I have written here the net outward flux, and I have divided the net outward flux with the differential volume. If you divide the net outward flux with the differential volume, then you will get the divergence. So the divergence will be equal to, the divergence will be equal to 1 by H1, H2, H3, partial derivative with respect to Q1, V1, H2, H3, plus partial derivative with respect to Q2, V2, H3, H1, plus partial derivative with respect to Q3 and V3, H1, H2. You have to remember this term, this mathematics, to find out the divergence of a vector function. So in curvilinear coordinates, two things are very important. One is your gradient and another one is your divergence. In the previous video I have discussed about the gradient of a scalar function, and in this video we have discussed the divergence of a vector function. And in the next video we will discuss about the curl, and also we will discuss about the Laplacian. These are also very important for exam point of view. Thank you.